Hello and welcome to the chapter on expressions and control flow in PHP. This lecture and the video and the audio and the slides are all copyright Creative Commons attribution. So basically expressions are a real essential part of a language. If you ever sort of design a language, one of the critical things that you design is how expressions work. And so expressions are kind of complex things like x plus y plus z plus 42 plus something that eventually comes down to a value. And we often see these on the right side of assignment statements as compute this thing, produce a value, and then stick it into a variable. And it's just, you can use expressions all over the place. The typical thing that we do with expressions is we take variables and constants and we combine them with various operators. And this is the operator page from the PHP.net. And this is showing you all of the various operators. We'll cover a few of these, and these operators are same as many C-like languages, but then there are a few that are different. So I'll feature a few of these things. So some of you may not have seen increment or decrement operators. String concatenation in PHP is a dot, which turns out to be my absolute favorite way of doing string concatenation. I wish all languages did it. Most languages use plus. And unfortunately, it means everything's inconsistent. But most languages use plus for string concatenation. I love the dot, but most languages use the dot for other things like object-oriented notation or other things. The equality operators, and again, I'm always thinking of these things as, you know, that's asking a question. The identity operators we'll talk about. They're a stronger form of equality. And the ternary operator, again, comes from C and C-like languages. And it's a dangerous operator, but in certain situations, it can lead to very nice code. Another operator that we tend to avoid using, but sometimes we use them in very structured and stylized situations, is the side effect. And if you look at the bitwise operators, those are very old school, and I literally haven't used a bitwise operator. I might someday, but they're for masking and shifting. That's the old days. So the increment and decrement operators are side effect operators. And so if we take a look at this code here, my pen's still working? Yeah, if we take a look at this code, here's your increment decrement operator, the $x++. And the way that works is this little sub-expression from here to here both retrieves the value of $x and adds one to it, stores it back, and then in this case the old value of $x participates in this 15 plus whatever. And so this becomes 12, but then as a side effect x is 13. So x becomes 13 as a side effect of that plus plus. So it retrieves 12, so y ends up being 27, which is 12 plus 15. And so that's a side effect, but as a side, they're side effect operators. And we tend not to use these except in highly stylized situations. We don't just use it to save ourselves a little bit of time. It's much better to add a bit of explicit code like we have here. So if you really want to take the old value of x to participate in this 15 plus x, and then you want to add 1 to x, just be explicit about it. Because you could put this statement before or after that statement, and then you've sort of done it. Now, if you do plus plus $x, then that is a pre-increment, which means that it would be the same as moving this line up to here, which means it does the increment first, and then the x participates. And so, again, we tend to avoid these and tend to write more explicit code unless we have a very, very, very specific reason. And there's not a lot of those reasons inside PHP. One of the things I really do like a lot about PHP is the string concatenation. Oh yeah, I love me some string concatenation with a dot operator. It's just awesome. Like all concatenation, it doesn't add anything, and so if I want my little space here between hello and world, I got to put a space in the string, but it's nice. And as you see how operators tend to work, this operator, let me clear here. This operator here knows that its two operands are going to be strings. So while these are strings, if you put a number like 12, it'll force convert that to be a string. because the dot operator says to my left and to my right there shall be strings, and if they're not strings, I shall make them strings. So I mentioned the equality and identity, and the all C languages basically have the double equals operator. Remember, equals is assignment, which is really, I wish it were an arrow, but that's how it goes. My favorite operator would look like this. That would be my assignment operator, but that's just less than or equals to, so no one does it. Okay, so we'll give up on that. It's my dream, but I can't go back in time 40 years and get all this stuff fixed. The equality operator is asking the question, is this equal or not? The result of an equality operation is either a true or a false. And so these take two parameters and then produce a true or false value. Now the interesting thing is, for those of you coming from just about any other language, is the aggressive type conversion that's going on here. And so this statement here, this first statement, this if 123 equals double quote 123, it's like that would fail, but not in PHP. PHP says, oh, I'm going to look to the left, I'm going to look to the right. Can I do a conversion? And what's a string and a number? But can I convert that string to a number and achieve the equality? And the answer is yes, it can. If that's your intention, that's a powerful contraction. You don't have to put int, parenthesis, or anything like that. So I love it, but you got to be careful, because if you didn't mean that, or if that is was a string variable and you really didn't intend it, it's going to try to convert it. And it gets even crazier. Right, in this next one, we say if 123, a number, is equal to the string 100 plus 23. Well, this is a plus operator, and it's like normally we'd be looking for numbers. Oh, wait a sec, I convert that string automatically, and that's true as well. So it actually, mathematical calculations can do string conversions as well. Okay, how about this one? False. That's a constant. That's the logical constant false. Is that equal to the string 0? This is even crazier. Well, it turns out that when false is converted to an integer, it turns into 0. And when quote 0 quote is converted to an integer, it turns into 0. So that's equal to. Okay, here's a crazy thing. Parenthesis 5 less than 6. If the parenthesis 5 less than 6 is this equal to quote 2 quote minus quote 1 quote. You're like, whoa, that just looks like it's impossible. Well, this is a logical expression that evaluates to true, which is equivalent to 0. No, I'm sorry. Erase, 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 erase. I said erase. There we go. So let's do this again. So this is a logical expression that is true, but it can be converted to a 1. There you go. So look at this. We're subtracting two strings, but the minus looks out, says I can convert that to a number. I can convert that to number. It becomes 2 minus 1, which becomes 1. So this one and that one are equal. Crazy. Again, I'm just showing you just to sort of see the kind of crazy mechanics that we got going on here. I'm showing you this to show you the crazy mechanics that we've got going on here. And this last little example, this evaluates to true, and this is the constant true, and the triple equals is exactly the same as, meaning that the triple equals does not look to its left and right and attempt to do conversion to make these values equal. So you will see as you look at online documentation, this notion that false becomes 0 and true becomes 1, false equals 0 and true becomes 1, or can be converted to 0. Golly, I got that wrong. True can be converted to 1, is something that requires the triple equals operator. And so if you look at this function, Stirpose, which finds one string within another, it returns a false. But if the string matches the first character, it will return 0. So you have to be able to distinguish between 0 and false. And if you use double equal, you cannot distinguish between 0 and false. But if you use triple equal, which refuses to do any type conversion and insists that both the type and the value are equivalent before it becomes true. So here's some examples of the use of the Stirpose function. So we have our variable hello world, and we are going to echo the position of WO. And so that's in position 6, of course, since the 0th position, 0, 1, 2, 3, 4, 5, 6. That's the 6th position. If we look at where the HE is, well, that ends up being 0 because it's the 1st position. So that's completely natural. And if we look at where the string ZZ occurs in there, it returns false. So this returns false. And then false is this non-existent infinitesimally small string. So false doesn't print out as F-A-L-S-E. False prints out as nothing. Okay? So let me clear this a bit. So now if we start looking at some of these things, if we're using double equals to compare to false in these two statements, well, if the position, where is HE? Well, if it finds it, it returns 0. And so is it equal to false? And the answer is yes. And so that's the wrong answer. Okay, if you change it, right, you say, so if we look at where ZZ is, well, that returns a false, and that gets it right. If we look for, but if the right way to do this is to say, if the position HE, which is going to give you a 0, because that is found, is not equal. So this is the triple equal. So there's the super equality and the super not equality. It's just like the not of the super equals. If the return value here is not exactly the same as false, echo right, which means we found it. And we found it at the 1st position because it returns a 0, which is mathematically the same as false, but not when type is considered, it's not. Okay? So this is wrong, right. And this one here, if we're looking for the string ZZ, this is going to return a false now, not a 0. And that is indeed completely equivalent to false. Okay? And then just to sort of reiterate, using print R, which we talked about earlier, it will not print out false, and print won't print out false. And that's why you use var dump, because var dump does print out false. So var dump is a little wordier, but it does, false shows up. I mean, the problem here is, you know, these falses would print out right there, but they don't. Right? These falses print out right there, but there is nothing, infinitesimally small. Okay? So ternary operator. This is really comes originally from C, and again, it's really a shorthand for an if-then-else, basically. And it's nice, but you can kind of get in trouble, and we tend to use it very idiomatically, where we don't just use it in all situations. Even a relatively short if we'll make as an if-then-else, and we'll actually be very explicit about that. But there are certain situations where you get tired of these like 5-line if something else, 5-line things just for the simplest of things. And you're looking for, is this variable set? Is this variable greater than 0? And you're often doing it in the form of an assignment statement. So if we take a look at here, well, in www is 1, 2, 3, and we ask the question. So the ternary operator has 2 characters. It uses the question mark and the colon. So the way I think about this is the first part is asking a question, the second part is the true value, and the third part is the false value. It's just like an if-then-else. This is like, the second one is like the then value, and the third one is the else value. So this is like if, then, else. So we look at the evaluation. In this case, it evaluates, well, let's clear the screen here. So we look at this, ask the question, and that evaluates to true. So that means that this is the result of the overall expression evaluation. So it takes large and assigns it into MSG. Okay? And so that's how it works. If it turned out that, if it turned out that that thing was false, then the small would have been stuck in. Now, a common way to use this, for example, and to feature our modulo operator, which remember is the remainder in a division operator. If we take a variable, www, there, 123 modulo 2, this whole notion of modulo 2 modulo 2 means it turns out that it's 0 for even and 1 for odd. Oops, odd. So I'm not really very good. Clear. So the when you take mod 2, 0 equals even. For all even numbers are 0 and all odd numbers are 1. Whatever. So this turns out to be asking the question, is this equal? Is WW2 an even number? And so this will, for even numbers, it'll stick even in, and in odd numbers, it will stick odd numbers in. Now in this particular case, because it's 123, the remainder is going to be 1, so this little bit will evaluate to 1. So this little bit then evaluates to false. And so odd is what's assigned into MSG. Okay? So that's where we get odd coming out for MSG. Now, we can also shorten this because integer values can be sent to true and false as well. So because this question mark wants a true or false, if we take www mod 2, that turns into a 1. 0 goes to false, and not 0 goes to true. So this ends up being a 1, and so it turns into a true, and so that moves an odd into message, and so odd comes out. Okay? So these are probably silly examples. We would never write this code this particular way because it's a bit confusing, but it shows you how the ternary operator works. Side effect assignment. So we have our classic assignment statement. So, out equals hello. And again, I always think of these as having a direction. And sometimes, especially like when we're creating database queries, we take this string and it gets bigger and bigger. We concatenate to the end of it. Put something in, add something, add something, add something, add something. And so we do a lot of lines like this. Like, okay, we're going to concatenate a space to this. Out is equal to $out concatenated with a space. That adds one space on to the end. Well, we can take this contraction right here and show it as a special assignment operator. It's still an assignment operator. It's still kind of going in this direction, but instead of replacing the value, it appends to the end. And the append is because this is a dot. You can do a plus equals as well, and now that you're doing an addition. So count equals plus equal 1 means add 1 to count. Okay? And so all of these are some way of modifying the equality operator with another operator, and it basically says do this to the current value that's in out or count or whatever. And again, it's just a contraction form. And again, we use them sparingly. But you'll see them, so the programmer who wrote the code that you might be looking at might not be using them sparingly. So you need to know what they look like. Because that's part of what we're learning here is how to look at each other's code. Control structures are very C-like. The two-way if-then-else has keyword if, a logical expression that evaluates to true or false, and then based on the true or false, the true branch and then the false branch comes right after the else. So, yada yada, true, yes, print bigger, all done. And in this case, it is true because x is greater than 2. Actually, this should say $x. So there's a little typo there on that slide. Note to self, fix typo on slide. And so that's it. And curly braces are allow you to put more than one statement, right? Indenting has no meaning, but we indent just for our own cognitive happiness and safety. You can do a multi-way branch. You just sort of start with the if, and then instead of saying else, you just say else if. You concatenate those together, and then there's another logical question, and then a true block, and then you can have actually as many of these as you want. And when you're all done, and this is also option, you can have an else. And so you can think of this, it only does one of them, and it does them in order. If this is true, well, in this case it's false, it falls down, but then when this becomes true, then it runs that and continues. There could be many, many more of these else ifs here, But once one becomes true, it doesn't check the others. It's not like evaluate all of them and do the ones that are true. It's like evaluate the first one. If that's false, evaluate the second one. If that's false, evaluate the third one. If that's true, done. There could be hundreds below, and they would all be ignored. Curly braces are not required if you only have one statement as the object of the if. Okay? And so, but most people, even in this code, would not take advantage. Some people will put, if you didn't have this, one if, parenthesis, yada, yada, and then one relatively short statement on a line. They'll go that far. But this notion of if, else if, no one would write that. Everyone would write it by adding the optional but highly valuable cognitively curly braces. But you might see something like this, and you should be like, you are not a cool programmer if you write that way. But they are not required, and the thing that makes them not required is if there's only one line that's the object of the if or the else if, and frankly, you do that with fors and other things like that. I'm not a big fan of the switch statement, but you will see it. So the switch basically has a control variable, and you could think of this as checking these in sequence. Now it doesn't, again, check them all. It finds the one that is true, and then if it finds the one that's true, clear that. It's sort of like, come down here, check till you find one that's true, and then run that code, and then this break statement gets you completely out. And it turns out you can also, if you want, sort of bring this up on the same line. This is just a white space difference, white space difference. The other thing that's important is that once you come down into something, in this case we're looking for X, false, continue looking, true, run. What's missing here is there's no break statement there, and then it continues on. And then it breaks to get out. So the problem with this is, so this prints out X followed by Y. Please don't use this. It's just a bad way to write code. It's like, ooh, I'm showing off how spaghetti-ish I can make my code. But you will see it from old C programmers who are trying to show off their ability to write code that you can barely understand. So I want you to understand their code. Okay, looping structures. We have a zero-trip loop. The keyword for the zero-trip loop is the while keyword. And much like most languages, it has while, and then it has a logical operation that evaluates true or false. And that controls if the loop executes the first time, or if the loop, and then once the loop executes once, it controls whether or not it continues to execute. And then as soon as it gets false, then the loop ends. But this happens to be an infinite loop, and so it never finishes. So this loop never finishes. So this is a bad loop because it's an infinite loop. So you tend to want to have some kind of an iteration variable in a while loop that at least changes. And so here we set while to fuel to 10. We come into the while loop. Fuel's greater than 1, yes, print. Then we subtract 1, then we go up. So this will go like 10, 9, 8, 7, 6, 5, 4, 3, 2. Then 1 it'll come through. Then this fuel will become 0. Then it'll come up. It'll then ask this question, and then that will be what kicks it out of the loop. And so this one is a much better loop because it has an iteration variable. This is an infinite loop up here, and as such is not a happy face because that'll run forever until you hit Control-C or blow up your computer or shut it down or unplug it, and then the battery runs out. There is a minimum one-trip loop. It's called a do-while loop, and so it starts with a do at the top and ends with a while and logic statement at the bottom. And so it will always run this at least once, and then it will check. So it's up to you whether you want to construct a zero-trip loop with a while at the top or a one-trip loop with a while at the bottom. The other thing that's going on here is we're using a pre-increment operator, a side effect operator, that both adds 1 to count, and then the new versions, because the plus is in the front, it adds 1, and then the new version of count is what participates in this less than or equal to 5. Okay? The for loop is, well, it's from C, and as so it's succinct and a little bit tricky. But absolutely, once you know it, you will know the Java for loop and the JavaScript for loop and who knows what other crazy languages have borrowed the original C syntax. And it looks nasty, but it's not too bad. So the keyword, of course, is for, and then there are three pieces separated by semicolons. This is the starting part, done once before the loop starts. This is the test. This is the question, how long to run the loop. And this is the end of loop step, right? So we're going to add 1 to count. And this is a perfectly good place to use one of these side effect operators. So this is going to start count to be 1. It's going to keep running as long as count remains less than or equal to 6. So when count becomes 7, it's going to pop out. And then each time through the loop, count is going to go up. So it's like, 1, 2, 3, 4, 5, 6, and then done. Now this is a top tested loop in the fact that if the code comes in like this and this immediately is false, the loop will be executed 0 times. So it is a top tested loop, top test, also potentially a 0 trip, meaning this question is checked once before the first iteration is executed. So here's the bit about the loop starting and the maintaining true, etc. And it's a top tested loop. So there you go. The looping through an array is one of the prettier parts of PHP. I just love this because it's just so absolutely intuitive. In this case, I'm looping through a key value array where I have name maps to Chuck, course maps to SI664. And so I have my array, which is the stuff I'm going to iterate through. The as is a PHP keyword, and basically the k and the v are key and v. You can make I always use k and v, but you could use any variables you want. But basically, whatever this first variable is, it iterates successively through the key values, and v iterates to the values simultaneously. K and v are advanced together, and so this particular loop is going to run twice because there's 2 elements in the array, and prints out the key value pairs in the array. And interestingly, these do remain in order. Whatever order you put them in, they stay in that order, and so name and came out before course. Now there are things that you can do that causes the order to be changed or whatever, but they generally, as you put them in order, they come back out in order. Here is an example of looping through an array that only has values and no keys. And so away we go. It's just Chuck and 664. It will sort of put in 0, 1 for the keys if you use this k maps to v. You can actually just omit this. Of course, then you'd have to omit that. And then it'll just loop through the values if that's what you want to do. You can loop through the array using a count if it's one of these no key arrays. So I can construct a for loop that basically says for I equals 0, as long as I is less than count, count's a built-in function, how many items are in that array, which would be 2 in this case. So this part here is 2. So as long as I is less than 2, not less than or equal to, but less than 2, and then each time through the loop add 1. So that means that I is going to be 0 and then 1, and then stuff sub I is going to use an integer lookup to get the values. Now, I only show you this because you can construct this, but this is by far less elegant than the other way of doing this in that previous slide. This is a much more elegant way to do it if really all you want is to go through all the keys and the values. But you can create a counted loop in an array if you really want. So there's some loop controls that are taken straight from C and C-like languages, and that are the break and the continue. And break is a way to, when that break executes, it pops right out of the innermost loop. The continue says finish this iteration and move on to the next iteration, possibly exiting the loop. And so here is a bit of code. So we have, usually with a break, you have some kind of an if statement. So when this thing becomes true, break, and that just says completely leave the loop, just like in most languages. So even though this loop would go all the way up to 600 times, the moment count hits 5, and so count goes 1, 2, 3, 4, and then the loop starts for the 5th time, but count, this becomes true on the 5th time, and so we jump out at that point. So that could have ran a bunch of times, but because of the break, it didn't run at all. I mean, it only ran the first time 5 times. The continue is not an escape from the loop, but it's an escape from the iteration, the current iteration, and it jumps to the top of the loop. And so this is an example where I'm doing a comp modulo 2. If that's equal to 0, that's kind of an idiom. That whole thing right there is asking the question even. Is this an even number? So this is going to actually print the odd numbers out between 1 and 10, but not print the even numbers out. And if you look at the code, that's exactly what's happening. So when this modulo 2 is 0, then we do a continue. Now the important thing about the continue is it runs both the end of loop operation and then asks the question. Okay? So the continue runs both this and then asks the question. So it does this first, adds 1 to count, otherwise the loop would never finish, and then it asks the question, right? That's the second thing. And then the question, sometimes it'll continue back down the loop, and then when that thing becomes false, then it exits the loop, and that's how the loop finishes right there. So there's a type conversion. PHP does a lot of type conversion for you, so it's rather rare that you have to force types to convert, but you can put casting operators in front of things, and you can if you want. And so a casting operator is a type in a parenthesis. Here's some example code. We can divide A and B, well, those are just integers, but then you'll see that C automatically becomes a floating point number because of this division, unlike Python. And then we can do things like add the string 100 plus 36.25 plus true. Well, that turns into a 1, and this turns into a integer 100, but then this turns them all into floating point, so that becomes 137.25. So watch that one closely, look that one over. And if you just look at your type conversion, you get your type conversion goggles on, then everything is pretty good. So here we go. We say this would be implicit, right? Because the dot operator forces its operands on both sides to become strings, the concatenation operator. But here I'm taking this D, which is itself a floating point, and casting it to a string, so it participates in this expression as a string. So that's kind of useless because the dot operator would have just done that. But this one actually is more useful because now this int 9.9 says convert this thing to an integer and truncate, and then have that integer participate in the expression, which means that becomes a 9, and then 9 minus 1 becomes 8. Okay, so that is forcing a floating point. If you didn't put the int in, this would be 8.9. because the integer would have been converted to a float, but we do the int first. And the casting operators have very high precedence, so they associate very closely with the variable that they're right in front of. If you want to change that, you can throw parentheses in, wherever you want to force it, but if you don't change it, the implied parentheses are right immediately to the right of the casting operator. And again, we talked about this a couple of times. The plus operator wants to be an arithmetic operator, not a concatenation operator. So in this case, it's smart enough to say, I got to turn that into a number, and that is already a number. So I'm going to add these things together. Well, what does it do? It actually doesn't blow up in this case. It actually looks at Sam and says, I can't convert to a number, so I'll assume you mean 0. So if you're converting the string Sam to a number, it converts to the number 0. And so that's why F becomes 25, because it's 0 plus 25. So again, you could say wow, that's the greatest thing ever, or that's the worst thing ever, and you'd probably be right both times. I think of it as power. I can do what I want, but I'm also responsible for doing what I want in PHP, and I love it. If you take sort of the flip side of everything, you got Sam concatenated with 25, so the concatenation operator is looking both directions and is thinking, I'm making these things a string because I'm a string operator. So I'm going to force them to be strings. So that effectively forces the 25 to be a string. And so now you see the string Sam concatenated with the string 25. And the result of that is also a string. Okay, so that's casting. It's rather rare. Probably the only time this, when you really want to do it is probably something like forcing an integer truncation to say truncate this. So just comparing PHP and Python, Python is a lot more traceback happy, right? So in PHP, you want to add the string 125, you just do it, and it works. If you want to do Python, you have to say int, and it works. If you want to concatenate 100 and the string 125, 100 concatenate with 25, you just use the dot operator. It knows their strings, and away you go. In Python, the way you do this is you say convert the integer 25 to a string, and then the plus becomes a concatenation operator. So in this case, we're using the plus both for concatenation and for addition, whereas in PHP, we're using the plus for addition and the dot for concatenation. This is one of my favorite features of PHP, actually. But again, like I said, the world will never adopt my idea. I think it's the best idea ever. But no one cares. So if you were trying to do this Sam plus 25, PHP goes like, hey, you don't make any sense, but I'll turn that into a 0 and happily give you 25. If you try to convert with PHP Python the string Sam to 25, it does not give you 0. It gives you back a traceback and a sad face. Python's just trying to make you be explicit, and PHP says you got the power, use it. If you tell me to do it, and I can figure out some way to do it, even if it's a little dysfunctional, I will do it. I'll continue. Python is like, I quit. I'm going to blow up, and I'm going to tell you because you need to know this stuff. That's why it's good to learn Python and then like code in PHP when you sort of got your game on a little bit more. So concatenation is trying to convert its operations, its operands to strings. It's looking to both sides. And so the false, as I mentioned, is this infinitesimally small string. So you see AB, but in the inconsistency department, true converts to the string 1 when turned into a string. False doesn't convert to 0 and then become a string 0. It converts straight to a string as nothing, but true converts to a string 1. Why, oh why? Why, oh why? I don't understand. No, well, it is what it is and probably will never change, but I would call this an imperfection. It's always bothered me. I'll spend hours looking for that little false thing. I print it out like, oh, I can't see it. So here we are. We kind of roared through a bit of the expressions that we have, and operators and conditional structures and looping structures. And so this is kind of your basic constructing of code. Thanks.